Hello everyone, jrrom here, and this is an extremely brief introduction to JQ. JQ may be one of the most unique programming languages of our time. If I were to ask you what you thought it stood for, then you might answer or you might assume that it's the short form of JSON query. However, according to one of the authors of JQ, that assumption is false. This is just one of the many ways that this programming language is misunderstood. JQ is not just for handling JSON. It can even serve as a rudimentary general-purpose programming language, a stream editor, and even a peg parser. JQ is so complex that it can be implemented in itself. Here we have JQ implementation of JQ. It's easier to call it JQ square with that many JQs. All right, and here we have from the GitHub wiki, JQ as a peg engine. And here I have a small example of running JQ in a more general purpose use to generate the fizzbuzz sequence. All right, nice. All right, first I want to give a small disclaimer. I must admit I am not a JQ expert. I just wanted to make this video after completing the exorcism JQ track for fun. I urge anyone interested to go look into the documentation and manual themselves. The main purpose of this is to show off a cool thing I found, and any errors in this video are my own. Just wanted to show off my achievements. All right. Basics. So, hello world. If I had to say something about the general vibe of JQ, I'd say it's a functional programming language out of necessity rather than by choice. The first thing you need to understand is that everything is either a filter or a construct that acts on filters. Let's look at a quick hello world. Don't mind the JavaScript. It's just there to generate values to be consumed by the JQ. So here we pass hello world. Okay, all right. And we run this and we get hello world. This is the identity operator period or dot, which returns whatever is passed to it. Here we have a small example of object indexing. So we can use object indexing for more useful filters where we need to extract the value of a key from an existing object. So here we have an object students with the name and marks they each scored. Let's create the JSON object. Here we have the object to be passed. Let's get the value of John, which is 50. This is another alternate syntax. You can use either square brackets or dot syntax like this, John. However, you must use square brackets when using a key like John Smith with a space in between, because I think that's much more cleaner. Here we go, Bob, 75. Here, John Smith, we can use the square bracket syntax. Boom, 100. Note, we can also use question mark when we do not know if the attribute exists and we want to query it without errors. So remember in the previous object, we did not have a dot name. There's only John, Bob, Tom, and John Smith. So when we run this, it would return something like null. Let me show that. Let me go back 1 second. Let's do dot name. Boom, null. So there. And then we have pipe operator. We use it to chain values and apply many filters in sequence. So first we get the value of John, which is 50. And then we make it a string, which is 50 as a string. Here is an example of another pipe, which is not the JQ pipe. Next, we have arrays. So arrays are a language construct for arranging a sequence of values in JQ. So here we have an array of objects. Let's make it into JSON. There we have it. Don't worry about the JavaScript. It's just what I need to pass JSON and org to JQ. Otherwise, I wouldn't do it. Here we have array indexing. We can use array indexing to query them by index position. This is helpful in iteration and arrays created by range. Don't worry about range. We'll see. Oh, we already saw it in fizzbuzz actually. We created a range. Can I show you right now? 1 second. Let's do range um 0 to 10, which is 0 to 9. There you go, example. But if we go back, here we can see what would be the first index. That would actually be Bob, because JQ is 0 indexed. Boom, Bob. That's why his photo is there. Yeah. All right, next. Here we have streams. We can separate the different items or elements of an array and evaluate them separately. That's what I mean by stream. We can also use the syntax of closing square brackets to put the stream back together. There you go. You can see it's now inside an array. If we don't do this, then it's separate and it gets evaluated separately. Okay. Here we have data manipulation. What I just wanted to cover is that I wanted to show off the foundational data manipulation constructs in functional programming languages, including JQ. So we can do most of the important querying with their help, and they replace regular for or while loops. So here we have map, which is equivalent to map in most major programming languages. It's from functional programming, but now it's implemented everywhere. You see it in Python, you see it in JavaScript, etc. So we have data, pipe, map, filter. This applies a filter to every data element. Select, which is equivalent to filter in most major programming languages. I know it's filter in JavaScript. So here you do data, pipe, map, select, filter. So this would be used, for example, if you have a class of students and each student has a mark and you only want to select the students with marks above a certain amount, let's say 50, then you would use map select, let's say dot mark is greater than 50 or something like that. Don't quote me on that. Reduce, equivalent to reduce or fold. It's in most major programming languages. In Haskell, it's fold-L. It's a complex construct in JQ, so we can do data, pipe, reduce, dot, open square bracket, close square bracket as a variable with the dollar sign, initial and update. So this goes over every data item and applies the update to get the new value of initial, which is passed over to the next data item. So it can keep accumulating to initial over and go over every data item. Here we have variables. So variables solve a very specific problem. They are pretty complex. Their main use case comes from the fact that it is hard to keep constants in JQ. Variables were made specifically to solve this. We really don't need to use variables in most situations, but there are some situations where they are vital. So here is a very basic example. So we have an old value of the array here, 1, 2, 3. And then here we make a modification to the array. We increment everything by 1. As you can see, the old array no longer exists because it was passed and changed. But what if you wanted to access a value from the old array? So what you can do is you can do this as a saved value and then pipe it to the next. And then here you can access it even though it does not exist anymore. So we access the second index of the old array, which is 3. And we save it and we can still access it later. There we go. Functions. To call JQ functions is a bit misleading in my opinion, since they are not like other functions in other programming languages. They are a bit closer to glorified macros if you do not use variables inside them. I would say functions are a complex type of reusable filter that is more ergonomic than repeating the same code. So here's an example. John is given to say hello. Say hello is given to give message, and we pass the arguments good morning and how are you. We separate arguments by semicolon. So we give message greeting. And finally, the original thing that we passed is coming up here in the form of dot. This is a form of point-free programming where we do not need to specify the piped value. We do not need to specify, oh, we get dot. That's already implicitly accepted. So it's given, and then finally we get good morning, John. How are you? From this. Thank you, Snoopy. All right. Miscellaneous. So this is just some extras I wanted to cover. We can use the comma operator to evaluate multiple filters on an input to produce multiple outputs. I think of it as a sort of deconstruction. Here we go. We have multiple streams. We have Joltic and electric on evaluated separately. That's just what I wanted to say. And if you do anything on this, it will be evaluated separately. So let's do this plus high. No, or high plus this. Boom. It's evaluated separately. So we get high Joltic, high electric. All right. Then we have the default operator. So if you just do this, then you run it and then you see Joltic, electric, correct. Ash, null. But why does null come is because Ash, this object with Ash in it does not have a type because Ash is not a Pokemon. So instead of that, we can do the default operator dash dash unknown and then Ash gets unknown. All right. Here we have object construction. JQ is not only used to query objects, it's also used to construct them. So here we separate the different objects in the array and then we put them back together. No, we don't put them back together. We convert them to a new object with a new attribute object entity. Like that, we can construct new objects from scratch. Here we have assignment. So we can also assign to a pre-existing object a new value. So we have name Joltic type entity, name Ash type entity. And as you notice, it was not type entity before, it was type electric. And in the case of Ash, there was no type at all. So we can also assign new values. Finally, let's go over quickly some built-ins. We have toNumber. We get 1, 2, 3. We have toString. Boom, 1, 2, 3. We have length. I wanted to show you that it's possible to get the length of not only strings, but also arrays and objects. Let's show you the object now. 1, all right. Has key. So this is to check if an object has a certain key or not. It's true. Ash does have a name. All right. Then we can also delete a certain key. We can delete the name from this and we get age. All right. Now we have split and join. This is pretty similar to Python. We split it. We get hello world. And then we can also join it back and hello world. All right. Finally, I'm going to do some live problem solving. I'm going to do a live challenge. I'm going to ask DeepSeek to give me some queries and I'll be using pokédex.json from Purukito. And let's get into it. Let me just copy this. Let's do gptel. All right. I'm going to add the file of the presentation file. And I'm going to not include the reasoning. And I'm going to use DeepSeek Flash. All right. All right, here we go. At position 24 of the array lies a very famous Pokemon. Print its ID, name, English, and type. All right. This is a bit more specific than I'd like. Thought I'll just give you the top 10 Pokemon with the most HP, but we'll do that later if it doesn't ask. All right, let's get to it. I'm going to split. Let's do it live. So first thing you want to know with JQ is that you can use the JQ command with N to evaluate without passing in any JSON file. Like this, you can just evaluate 1, 2, 3. We can do map to string. And boom, it's to string. All right. So let's do the first two. We need to find position number 24. And we need to get the array stream. Okay. And then we'll get back to it. Let's make it easy to read. So we need to pass in the file pokédex.json. Let's get number 24, shall we? It's actually 23 because it's zero indexed. Ah, that's Arbok. Looks like the DeepSeek has it wrong. Ah, Pikachu is number 25. Oh my goodness. Let's get the name. It's a it is Pikachu. Nice. Let's make a new object. Let's do this. Let's do name. Let's get the type now. I'm thinking type. Um dot type. Let's do JQ. Let's do dot 24 as P. We get new object. Name is dot P dot name dot English, and type is P dot type. Let's see. I don't know anything about the JSON as of now, and we got the type. It's electric, but as you can see, it's actually in an array because Pokemon can have many different types sometimes. All right, I'd say that's successfully completed. It is completed. ID and we also need to give. It wants the ID. Oops. Let's do ID. P.id. Boom. There you have it. Object construction. Let's do array streams. Print the English names of the first 10 Pokemon. How about we print the names of the Pokemon with the highest HP? Let's do. Okay, JQ. Let's do Pokédocs. The JSON. We need to get dot for each one. Sort. Oops. I'm doing it for everything. Let's see. Let's JQ sort. We need to sort by, let's do dot base dot HP. And let's do, we want 10. I forgot the syntax. Let's do this sort of thing. It's actually capitals. All right, what we do now is we do, let's say, dot base dot HP sort. Let's do reverse. Let's do 10. That's wrong. That's wrong. We forgot to put dot. Dot 10. The top 10. So the highest HP Pokemon is 255, 250, 223, 200, etc. Let's go back. Data manipulation. List the English names of every Pokemon whose type contains electric. Then give a count of how many there are. All right. We want to list the English names of every Pokemon whose type contains electric. That would be a select. That's true. Ah, that's why it said map and select. Fine. I was wondering why map was there. JQ. Let's do map select mm, dot type contains. Let's do electric Pokédex JSON. Ah, yes. When contains, you have to put the string in an array. Oops. We have the entire value, so we just get the name dot English. We get the like this. There we go. We have all the names of all the electric Pokemon. And I'm gonna cheat a little bit, but what we can do right now is we can actually do a count. There you go. Yeah, 57 electric Pokemon. That might be wrong. Let's see. That's just what's in the JSON file. That's how you do it. I would do it properly, but I'm kind of lazy. Let's do it. Let's do. Yeah, I'm actually kind of lazy. Let's say that's success. Okay, reduce. Compute the average base speed of all the Pokemon in the dex. Mm, so first we need the amount of Pokemon in the dex. That's a use case for variables. Let's do JQ. Length Pokédex. We have 898 entries. So we do first of all, let's save the current state of the Pokédex as original. Then we do O length as L length. Let's do L. Okay, it works. This may look a little bit weird, but it's good. Let's not. And then here we can type. Okay, now we need to find, what was it again? We need to find the average base speed. Where's speed? Speed is in base speed. So let's do O dot. To find the average speed, we only need to extract the speed out of everything. So let's do this dot base dot, oops, speed capital. We'll get something like that. All right, works. Once again. All right. Now we have got the speed. Now we just need to reduce. Reduce as, let's do X. We have the initial value 0. We got that plus X and Pokédex. That's a lot of speed. Now we do dot divided by length Pokédex. That's your average speed. 65.905 repeating, not repeating. Long. It's a very long decimal. Yeah. Then we have variables and object construction. ID to its English name. We already did that. Functions and string interpolation. Takes a Pokemon entry and produces a string like Pikachu is 25 and has types electric. All right. Kind of basic. Let's do def describe. It takes an index. We put takes an index, and we would say dot I dot name dot English is dot I dot ID and has types dot dot type. Is that good? And we just do describe 25. Now does that work? Raichu, Pikachu. There you have it. Let's go. We got it. The reason why it's like that is because it's an array, so it's making an array into a string. That's fine. I'm too lazy to fix it. Let's leave it. Ah, delete. 1 second. All right, next. Final boss, variables and reduce. Find the Pokemon with the highest attack stat. Print its English name, its ID, and its attack value. It's saying to use reduce. I don't know if we should. Let's see. First of all, let's break it down. Let's get the base attack. But in doing so, we lose all the data. You're right. Let's use a reduce. Let's do reduce dot as Pokemon. Initial value will be, let's say it's the first Pokemon, 0. This is initial values only evaluated once, so we don't need to worry about it being turned back into 0 in subsequent executions. Let's say if dot base dot attack is lower than p dot base dot attack, if then dot is equal to p, else dot end, and I forgot to close the parentheses, and we got Kartana is the highest attack out of any Pokemon. There you have it. There you have it. All right. Let's see. Oops. Sorry. Made my. All right. There we go. Now it's more comfortable. Is it me or did the font change? Anyways, don't think about it. There we go. We have Kartana is the strongest Pokemon. Let's verify this. Let's do JQ the base attack sort reverse Pokédex.json. And we get the first. There we have it. That is true. Kartana is the highest base attack. I left one question at the beginning, if you recall, that I found the top 10 healthiest, highest base HP stat, but I could not find a list of those as objects. Let's try to solve that right now. It might be a bit complex. So I'm thinking we do dot base dot HP. I'm thinking I have a dumb idea. Let's see. If I do, if I say this is HP, I give it this value. And let's say I give the object as dot. Then if I, oh, it's really struggling. Stop. My Emacs is glitching out. Anyways, I wonder if we can sort this. And then we do a reverse. And then we do, um, okay, let's do not do dot object. Let's do name or something. Name as, so first it sorts on the name and on the HP. That's my thought process behind it. Let's do dot um name dot English. Let's do sort in reverse. Oops, forgot something. It works. Okay, now like this, we can find the top 10 Pokemon. Let's do it. We do like this. 1 second. Let me put this in less. There you have it. Highest is Blissey, Chansey, Guzzlord. I don't know half of these. I stopped playing after Emerald. Okay. I'm pretty sure these two are an Emerald though. I have no idea about Guzzlord. Regidrago. Wobbuffet. Wailord, I know. Snorlax, I know. Anyways, I guess I would call that it. We have shown filter, we have shown map, we have shown reduce, we have shown all the basic functionality of JQ. Okay, so thank you for watching. All right.